Hello, welcome to your Math 8 Learning. We're going to be talking about linear models today. Basically, guys, we're not going to prolong this part of the lesson because we're just going to be talking about learning linear models and just looking at whether the models are good for the data or not. The goal of this lesson is to compare and contrast different linear models and determine the range of values for which a given model is a good fit for the data. Does the model fit the data? Does the model represent the data appropriately? And if not, can it be corrected? And how can we correct it? And if it doesn't work, if the examples work, and how does it work? So we're just going to take a look at a few examples and talk through them, okay? So looking at example one, we're looking at the moon. On the first day after the moon is 2% illuminated, on the second day it is 6% illuminated. The first question asks, do we have enough information to calculate when the moon will be 50% illuminated? The second question says the moon's surface is 100% illuminated on day 14. Does that agree with question A? In question A, were we able to predict when the moon will be 50% illuminated? So, do we have enough information to do this? And is the percentage illumination a function of the day? So as you go through this lesson and complete the practices and everything, you'll realize it's a lot of application and practice, only because we want you to be able to analyze models and to look at them and see if the data matches the model, if the data goes with the model, okay? So the first one, does this data match the model? Do we have enough information to calculate when the moon will be 50% illuminated? No, we do not. There's not enough information here. And no, we cannot make prediction because we don't have enough information in part A. And is the percentage a function of the day? No, it's not, because they did a very bad job approximating the data. Okay, the model's not very good, the data's not very good, so we can't do what they're asking us to do. So here you're going to have to use your math judgment. You're going to have to trust your judgment. Okay, now we're going to take a look at a graph. We're going to have to sketch a line. Yeah, we're going to have to sketch a line, a linear function that models the change in the percentage of garbage that was recycled between 1991 and 1995. For which years is the model good at predicting the percentage of garbage that is produced? For which years is it not as good? So we're going to have to draw in a line or sketch in a line. So here is where we would have to draw in a line, a linear line, to see if we can get our dots on there. And a linear line is a straight line. Now, the line that we just drew, are all our answers on there? Did we get all the points? No, we did not. What years did we cover? For which years is the model that we predicted good for? I would say from 1990 till about maybe 2004-ish, okay? Not quite 2005. And for which years is it not good? Anything from 2005 all the way to 2015. Our linear line did not cover anything from 2005 to 2015. However, if you go and you pick another time period to sketch another line, so let's say we'll start, we could have started somewhere, yeah, like here, maybe. And that's not a straight line because I don't have a ruler, sorry. Did we cover majority of that line? Yeah. I should have drew that a little straighter, but I don't have a. Is that a linear function? It's meant to be, but my line is not straight. Please forgive me. Yes, that is a linear function. What time periods did that cover? But It does not, but but it does not cover a certain time period. It's not good for a certain time period. So we did that for two different reasons. We did that because one, I wanted you guys to understand that although you might find a good model for one part of the graph, it may not be good for another part. You might find a model that's good for one graph, but it might not be good for another graph. It might be good for one table, it might not be good for another table. However, you must be able to use your judgment, okay? Um, so it's not really, it really has to do with your good judgment. So a mathematical model is a mathematical object like an equation, a function, or a geometric figure that we use to represent a real life situation. Sometimes the situation can be modeled by a linear function. We must use judgment about whether this is a reasonable thing to do based on the information we are given. We must also be aware that the model may make imprecise predictions or may only be appropriate for certain ranges of values. Please remember that as you are going through the practices, they are application practices. They are to make you to so we can see how you're applying the information that you're given. Because truth be told, this is to apply what you know and to apply what you've been taught, okay? So if you please attend the Zoom so that you can ask your questions. I am waiting to see you there. Please come see me, send me an email. I am here for you. Those of you who have come see me, thank you. I look forward to continue seeing your progress. Complete the packets, come see me. I'm here 10:30 and 1:30 on the Zoom. If you need that information, email me, email Miss Reed, email Mr. Cave. They have that information. I hope everyone is being safe, and I look forward to seeing everyone in your progress. All right, have a good weekend. Bye bye.